Okay, in this problem, we are to solve this non-linear system algebraically, and we got to be sure to check for non-real solutions. We might see an I or two pop up. Well, you can see these are non-linear equations because the highest power is 2, not 1. So the first one is x squared plus y squared equals 8. That's going to be a circle of radius square root of 8. And so we're going to look at where that might intersect the second equation, 4x squared plus 5y squared equals 41. That, my friends, is an ellipse. So we're going to try and do it algebraically. We're going to use elimination. And so it's similar to how we would solve a system of linear equations. We're going to multiply, I'll call this equation 1, and I'll call this equation 2. And we're going to multiply equation 1 by what? Well, what would you say? How about by negative 4? Why by negative 4? So that I have a negative 4x squared. That's the opposite of positive 4x squared. And when I add those together, then I will get no x squareds, and I'll just have an equation in y. It'll be a quadratic equation, but it'll still be just a single variable equation. So here we go. We're going to keep equation 2 the way it is, but I'm going to multiply equation 1 by negative 4. So negative 4x squared. It's going to be minus 4y squared. And on the right, make sure you do it all the way through. Negative 4 times 8, that's negative 32. And then we're going to keep equation 2 the same. So that's just 4x squared plus 5y squared equals 41. We're ready to add now. And so we do get those x squared terms add to 0. I got negative 4y squared and a positive 5y squared. That leaves me with 1y squared, because 5 minus 4 is 1. We don't need to write the 1. I have y squared equals negative 32 plus 41. That's 41 minus 32. Oh, that's 9. That's a perfect square. And that tells us that y is equal to plus or minus the square root of 9, square root property, which is plus or minus 3. So y can be 3 or negative 3. We're looking for ordered pairs here that make both of these equations true at the same time. So we're going to now find our x values. Now notice that y is 3 or negative 3. So I'm going to start with y equaling 3. And I can use either equation of my original equations. I'll do the first one. X squared plus 3 squared equals 8. Well, that's x squared plus 9 equals 8. Subtracting 9 from both sides, I get that x squared equals negative 1. So x is plus or minus the square root of negative 1, which is plus or minus I. That's right, I has made a return. It's back. And so there's two first coordinates that go with a second coordinate of 3. But notice what happens if I let y be equal to negative 3. I get the exact same values, because x squared plus negative 3 squared equals 8 gives me the same solutions for x, because negative 3 squared is also positive 9. So x squared is negative 1, and x is again plus or minus the square root of negative 1, or plus or minus I. So if y is 3 or negative 3, x is going to be I or negative I. It can be any one of those things. So I'm going to write my solutions here. I've got 4 of them, 4 solutions. None of them are real because they all have an imaginary first coordinate. I've got I can be paired with 3. And I've got that I can be paired with negative 3. I also have that negative I can be paired with 3. Or negative I can be paired with negative 3. And this really tells us that these two things, a circle and this ellipse, don't intersect, because we have ordered pairs, solutions that have an imaginary first coordinate. And we can show that as well. If we go to a graphing calculator here on, say, Desmos, and put our equations in, here's x squared plus y squared equals 8. You can see that's a circle. It's a circle of radius square root of 8. And then let's look at our other equation, 4x squared plus 5y squared equals 41. And we'll see that these don't intersect at all. Well, we zoom in real close here. It looks like they do. Man, look how close it is. Let's look at this point right here. Not quite, not quite. They come really close. but they don't intersect anywhere. The ellipse is always coming up here outside the circle. And I have a little trouble getting to it. There we go. Look at that. They don't intersect at all, which is what we showed algebraically, because we got no real solutions. We got non-real solutions.